So we are now talking about what is a union and how a union is different from a structure, and why we should think of a union instead of a structure. Now, to start with, let's say you have a structure. So you are saying you want to have a structure called 2, and it is having something like this. You have an array of 10 integers, and then you have an array of 10 floats. This is your structure. I have an array of 10 integers and an array of 10 floats. Now assume both integer and float occupy 4 bytes. So if you create a variable for this structure, you're going to see some 40 bytes given to A and another 40 bytes given to B. This is A, this is B. So you have 40 bytes here, A occupies 40 bytes and B occupies another 40 bytes. Totally 80 bytes. Well, that is how you get it. Now, nothing wrong. And you have memory allocated for A and B. So you can store data in A as well as in B. But what if I say I don't use A and B at the same time? Sometimes I use A, sometimes I use B. I don't use both of them at the same time. If I'm using A, I'm not using B. If I'm using B, I'm not using A. So if I have a scenario where only one of these two is used at any given point of time, not both, then I don't need 40 bytes for A and 40 for B. Instead, I can create just one block of 40 bytes and use that for both A and B. These 40 bytes may be used either as A or as B. Then I save 40 bytes. That's like saving 50%. Instead of 80 bytes, now I use only 40 bytes. But of course, provided you are using either A or B, not both at the same time. So to give you a simple example, let's say I have to take a C class and I have, say, 30 students. Then I need to take Java class in which I have 40 students. Now, I don't take both at the same time. Either I take C class or I take Java class. So I need to have a classroom that can accommodate how many students? If my classroom can accommodate 40 students, that's enough for me, because I can take Java class here, but when I'm not taking Java class and taking C, in the same classroom, I can take C. So I mean to say I don't need two classrooms, one with capacity 30, one with 40. Instead, I can have one with 40 that will satisfy my requirement. I don't need a separate 30 capacity classroom. This is not needed. Well, that's exactly what we are trying to do even in C. We don't want to have two blocks. We want to have one because we know we are not going to use both of them at the same time. So you can change this from struct to something new called union. So when you declare that as union instead of a structure, then you are not going to get this. This is not what you get. This is how it is. And C will find out the largest member. In this case, both members are of the same size. But in case if you have different sizes, it will find out the largest member and it will give memory allocation only for the largest member. and that area can be used either as the largest member or by other members. So if I change this example slightly and say I'm going to have not 10 but 15 here and 10 there, and then the amount of space I get is not 40, it's going to be 60. I assume integer occupies 4 bytes. So I get a block of 60 bytes. When I'm using A, I use all 60 bytes. And when I'm using B, I'm going to use only the first 40 bytes. This is your B that is going to use first 40 bytes. And this is A, which is going to use all 60 bytes. A would use all 60, but B is going to use only first 40 bytes. So like this, I can save the amount of memory we need to use, because especially in 70s, the memory was so little. Memory was really a big constraint. Well, today we are talking about gigabytes of memory, but in those days they worked with kilobytes of memory for quite some time. Then we got into megabytes and eventually gigabytes. But if you are talking about a scenario where only one of the members is to be used at any given point of time, you can think of a union instead of a structure. So that's the concept of union in C. But this is a little tricky, a little confusing, and highly error prone. What if you try to create a variable and then you are accessing A, but you are also by mistake using B? Then when we use B, you overwrite the value of A, because B, A both occupy the same memory location. They have same memory allocation. Now, I mean, if I ever create, let's say in main, if I say I'm creating a variable which is declared like that, union 2, okay, and some variable V, and then if I say V dot A of 0 is equal to 10, and by mistake, if I'm using the same variable but a different member, C won't stop me, but this is going to overwrite what we wrote into this. And if I put something like 1.5, now this will be gone. In that place, we are going to put this. So we can corrupt the data by making some mistakes unknowingly. So it's highly error prone. That's the reason why modern languages like Java, Python, C#, etc., they don't provide this feature for two reasons. Number one, we don't need to squeeze every ounce of memory. We have decent amount of memory nowadays. Number two, this is saving memory, but it is making your program a little more prone to silly mistakes and data corruption. So you need to know what a union is as a C programmer. You might even save good amount of memory through this technique. But in general, this is not preferred anymore because it saves memory at the cost of data corruption. And if you're not careful, it's easy to corrupt it. But anyway, this is what I want you to know about union. So that is the concept. You don't get memory allocation for all members. You get memory allocation for only the largest member. And that's where you are going to accommodate the rest of them. So that is the concept of union in C.